Hello everyone, this is Vikram and welcome to my channel. In this video, we'll talk about some of the core concepts in Python like variables and constants, keywords, how do we name a variable, and what are global and local variables. So these are the various topics that will be covered in this video. We'll talk about commands and why these are needed, and different types of commands like single line, multi-line commands, what are docstrings and in what scenarios we use them, and how do we access docstrings using doc attribute, what are keywords and identifiers, what are variables and constants and the difference between them, what is a variable scope. There are two different types of scopes, one is global and local. So this is not only for Python, so this is for every programming language. And how do we write a variable name, what are the various conventions to be followed, what is paid naming convention and why it is good to follow these conventions when you are trying to name any variable. How do we find the size of a variable? This is basically the amount of memory that a variable is going to occupy in the memory. And how do we find the actual size of a variable? By calling getsizeof function. And what are the various data types supported by Python, and how do you find a particular data type of a variable using type function? What is the use of none keyword and why do we use it? How do you find the memory address? So we say that every variable is stored in the memory, so that means it should have a memory address. How do you find the memory address of a variable using id function? And at the last we'll see how to convert from one data type to another data type, which we call it as typecasting in any programming language. And what is dynamic typing in Python? Basically, dynamic typing is very important concept in Python, and we are going to revisit this in the coming videos. But in the current video, we'll just understand what is this dynamic typing. Now let's consider this Python program. So there are almost 10 to 15 lines of Python program, and it is all clumsy. We are not able to understand anything. All we can understand is some keywords like import, def, and apart from that, it is very hard to understand. The reason why it is very hard to understand it, the developer has not written any comments. Now let's understand why comments are needed in programming languages. So as you had seen in the earlier code snippet, so this code is completely hard to understand because there are no comments to explain each line of the code. As the program gets bigger and more complicated, so they get more difficult to read, even for the same developer who is seeing that source code after a couple of years. So for this reason, it is always a good idea to add notes to your program to explain in natural language what that program is actually doing. So even in case of a small variable or a small piece of function, so if we can maintain a notes or write comments on top of that function or the variable, it becomes easier to read. So even it is for the same developer or for the other developer who is going to replace him, so it will be easier to understand. Now what are these commands? These commands are just a piece of text that we write to let someone know what a particular program is doing or what a particular block of code in that program is doing. Now writing commands is same in all the programming languages, but which character we use to indicate that it is a comment is different. In Python, hash is the character that we use before the actual start of the command to indicate that it is a comment, but in case of C language it is two forward slashes. So now here I've created a variable known as temperature threshold, so which is basically holding the threshold for that temperature. So now without these comments over here, it becomes difficult to understand. So why this threshold is defined here. So now if I can just write a small piece of text to show the other developers or someone who is reading this code, so it will be very easier for them to understand why I have to set this variable in the first place. Similarly, in case of C language, it will be two forward slashes. Now the same code, if I include some comments, so it will be very easy to understand. So here what I'm saying, here this line of code indicates importing a library. So I've just written hash import mqtt library. So now for the rest of the three parameters here, which are basically variables, so what I said, it is set mqtt config parameters. Similarly, these are various functions. So for every function, so I've written a small comment that indicates why this particular function is written and what exactly it is doing here. Now there are various forms of comments. So you can write comments in a single line, but if your comment is so huge, so you have to span to the multiple lines. So in that case you can use multiple techniques. So the first technique is using hashes in the multiple lines like this. So that means if you have large comment to be added, so you can put these hyphens like this. So these are the starting and the ending ones. So these are not needed, so basically these are not needed. You can just write the comment like this. But if you enclose them in these kind of lines, so it will be easier to understand, since this is a multi-line comment. So every line has to be has hash at the beginning, which indicates it is a comment. And also there is one more way of writing the multi-line comments. It is through these double quotes. So there are three double quotes at the beginning and three double quotes at the end. Basically this is a multi-line string. Even this also serves like a comment. Now what are docstrings? So docstrings are triple quoted strings. Basically these are also like multi-line comments, but these docstrings has special meaning in case of Python. So let's assume you have command line utility, so that you have downloaded. So let's say that it is a Git utility. So in order to work with the Git command line interface, you would like to see all the various commands that are supported by this Git utility. So what you will do, so once you write Git and then press enter, you will be getting all the various available options. Let's say that git config is one available option, but git config also has some sub commands. So you also wanted to know what are the various options that are supported for this configuration. Then usually you would do hyphen help. So this is true for any of the command line utility that you come across. That means if you want to know how to use a utility, so you can use hyphen help, which basically prints the help text for you. So similarly, Docstrings also does the same thing here. So let's say that you have a module or you have a separate library. So inside that library, there is a function that is defined. It is a standard function. So now you wanted to know how to use that function. Like what are the arguments that that function takes? What is the return value? Let's assume there is a function called adder function. So that basically takes two numbers, a, b, and which usually returns a plus b, which addition of two numbers. So now without actually knowing how to use that function, it becomes difficult. So what you have to do, you have to open that file and see how that function is implemented and how to use that. But instead, when you're writing a function, so what I can do is I can create a small description. So there is no standard way of writing this description, so you can write in your own words. But this description has to be enclosed in three double quotes, and it should be after the function definition itself. So after the def keyword, so there should be a comment like this. So now what is the advantage of using this comment? Now without actually opening this module file, I can read this description, the complete description, using underscore underscore doc underscore underscore attribute. So I'm going to show you how to use this when we actually go to the programming. So what I can do is I can just use this add and dot underscore underscore doc. So this will basically fetch the doc string for that function. So these basically serve like a help text. So it is always a good idea, the best practice to write doc strings. So doc strings are also kind of comments. So in which scenarios we use docstring? So we use for the modules, functions, classes, methods. For everything you can use docstrings. Now coming to the variables. So variables are one of the important concepts in any programming language. So before understanding variables, let's understand why these variables are needed. So let's assume without variables, how we are going to perform addition of two numbers. So let's say that addition of two numbers, like 2 plus 3, I wanted to add. Okay, so I've added in my memory, so the result is 5. But I wanted to share this result to someone, right? So I wanted to share this result to someone, but I don't want to share this number, but instead I wanted to share it with a variable. Let's say this one, I am just saving it as x. So x is holding the variable 5. So this x is 5, but x is here, it is 2 plus 3, it is 5. But this addition is not always 2 and 3. It can be any other number. It can be addition of any two numbers. So this 2 is also varying. It can also vary, and also this 3 also it can vary. So if anything is varying, we call it as a variable. So instead of hard coding them like this, what I'll do, I'll just say number 1 is equal to 2 and number 2 is equal to 3. Now I wanted to add both of these, so now it is number 1 plus number 2. So here number 1 can change and number 2 can change. Now the overall result I wanted to again store it somewhere, because even that will change with the number 1 and number 2. So that one I can name it as sum. So here sum is also a variable that depends on addition of these two variables, number 1 and number 2, and number 1 and number 2 are themselves are changing. So in case if it is instead of 2 it is 21, number 1 is changed, now it is 21 plus 3 24. So now sum has become 24. So what are these variables? Okay, so how these are managed in Python? So variables are just like containers, they hold information. So that information can be referenced somewhere. And one of the important use of using this variables is, so let's say I wanted to use this 33.3 in 100 places. And in 100 places, instead of writing 33.3 in all the 100 places, okay, so let's say assume that I have written 33.3 in 100 places. Now instead of this 33.3 I have to change it to 44. So now I have to search for all these 33.3 instances and then I have to replace it with 44. So this is very difficult task for me. Instead I'll store this 33.3 with some value with some variable name called x, and now I use that x in 100 places. Now in case if I have to change that variable value that x is holding from 33.3 to 44, simply I'll assign a new value to this x, which is x is equal to 44. So now I don't have to change it in 100 places, because in all the places this x gets replaced with 44. So these variables are nothing but a container. So that container is actually holding the value. So all the variables are stored in memory. And also they also provide a way of labeling data. So let's say this 33.3 it is related to temperature. So now I can put temperature is equal to 33. Here temperature is nothing but the variable name, and the value which it is holding is 33.3. And now this temperature, which is a variable name also called as identifier, so using this identifier called temperature I can access this value which is 33.3. Now, this temperature is also known as a pointer to the memory block, memory. Basically, this 33.3 has to be stored somewhere in the memory. Okay, so this is the 33 that got stored somewhere in the memory. Now, this temperature just points to the memory location of that 33, in where this 33 is existing in the memory. Why this is called as a variable in the first place? So it could be called with any other name. So we call them as variables because this temperature value, so now at present it is 33.3, but during the program runtime, so it can change it to any other value. It can change it to some 30, it can drop to 28. So that's the reason why temperature is a variable, so that is holding a variable data. Now how do you declare and assign a variable? So you declare a variable it is speed, and assigning value it is 5. So speed is equal to 5. So this is different for different programming languages. Here if you see, so I'm just saying speed is equal to 5. Now the speed can be an integer value, it can be a float value, it can be an integer value. So here I'm not defining what type of data that variable is holding, because in Python defining data type is not needed, because data type is calculated during the runtime of program execution. So in contrast, if I have to use the speed variable as 5 in case of C, so I have to define explicitly this is int. So int speed is equal to 5 semicolon. It says that speed is a variable of type int whose value is 5 at the moment. But in case of Python, it is completely different. So here speed is equal to 5. So at the moment speed is this 5 is like integer, right? So this is like an integer, but this value can change during the program execution. It can be changed to a float value, it can be changed to an integer value, it can be changed to a string. So this is called dynamic typing in Python, where the type of the variable is allowed to change during the runtime, which is not possible in case of C language. That means if the type of the variable is set as integer, it should hold only integer data. No. So why this kind of an arrangement is there in Python? So this basically comes under memory management in Python, so which we are going to cover in the coming videos. Basically, let's say that x is equal to 5 in case of Python. So now x is holding the integer data. So this 5 is stored somewhere in the memory. So now in case of Python, x is not holding the value 5. In case of C language, if I say int x is equal to 5, here x is holding the 5, which is a value. But in case of Python, x will not hold 5. X will point to a memory address that is actually holding the value of 5. So x is not 5, it is pointing to another memory location or memory address that is holding 5. Now during the program execution, I can say that x is equal to hello. That means here x is dynamically changed, that is the type of x is changed from integer to the string in case of Python. So now here x is now pointing to the memory location, so that is storing a string called hello. So this is called dynamic typing, and we call this as memory management in Python, so which will be explained in the coming sessions. So the name of this variable, right, it is case sensitive. That means if I say the speed is equal to 5, this is a separate variable. Now capital S, speed is equal to 5.5, so this is again a different variable because there is a change in this letter. Now average underscore speed, so this is again one variable which is basically holding a string type of data. So this is basically a float, which we will discuss in today's session. This print function, so we'll discuss print function in deep in the coming videos. So this print function, what I'm doing, I'm printing each and every variable, so which are separated by commas. So it is print function because it is open and closing the brackets. So each variable, this one and this one, I'm just trying to print here. Now assigning multiple values. So in the earlier slide, we had seen speed is equal to 5. This speed is equal to 5.5 and average speed is this one. So can I assign multiple values in a single line? Yes. So here I have a requirement like x is equal to 1, y is equal to 1, y is equal to 2.2, and then let's say z is equal to DevOps. So instead of defining them in 3 different lines, so I can use this kind notation, x comma y comma z is equal to 1, 2.2 and DevOps. So each one will be gets assigned like this. Here there are no semicolons in Python. In case of C language, let's say int c is equal to some 100. So this semicolon indicates end of the line in case of C language. But in case of Python, so the next line, the new line indicates the end of the previous line. That means x is equal to 1, y is equal to 2. So y is equal to 2 is defined in the new line that indicates x is the end of x is equal to 1. Can you also assign the same value to multiple variables? Yes, you can do. A is equal to b is equal to c is equal to 9. So basically all a, b, c gets 9. If you try to print them, you will get the 9 as the result. Now we are saying that x is equal to 1, y is equal to 2 and z is equal to 3. These are 3 different variables. So what if I wanted to write them in the same line? So you can use 2 different notations. So one is this notation. So the other notation is using semicolons and then writing multiple variables together in the same line. Here I'm just writing a is equal to 1, b 2, c 3 and d 4 in the same line, which basically is it is not a standard way in case of Python, because in Python you have to define new variables in the next line. So that is the standard and the best practice. Now end of the line. So what we said that in case of C is, let's say int speed is equal to, let's 100. So in order to indicate that this is the end of the line, so we have to indicate with semicolon. But in case of Python, so the new line basically indicates the end of the line. But if you have, let's say that if you wanted to add 1 plus 2 plus 3, so up to 100, but writing all 100 numbers in a single line is not possible. So if you want to span to the other line, so what you can do is you can use backward slash like this, so to go to the next line. So this one is as good as adding all the numbers till 6. So if you want to span across, so you have to use forward slash. So one more thing is using the brackets like this, so you can just use brackets. So all of these values will be taken as the single value, that is addition of 7 to 12, and the result is stored back to the sum 2. Here addition from 1 to 6 is stored back to the sum 1. Now let's come understand the important concept, the address of a variable. But before that, let's go to the VS Code and try to understand, execute some programs. So here I'm just writing a single some comments. So here commands start with hash, as we already know. So let's say that if I have to write my age is equal to 28. So here age is 28, but I wanted to tell it to someone that this defines age of someone. So I can write on top of it like set age here. So this is a simple command. So now command I can write before the variable or in line with the variable like this. So even this is also the most common thing. And now what are multi-line commands? So multi-line commands are the commands that span across multiple lines. So here in order to write multiple lines, so I can use single 3 quotes like this, or I can also use double quotes like this, 3 double quotes like this, or else there is one more way. So I can put, so let's copy them. So I wanted to basically comment these 2 lines, so I'll put hash before them, that's it. And in VS Code there is a shortcut, and this shortcut works for all the programming languages. So let's say you wanted to comment a few lines. Okay, so all you have to do is you have to select all lines, press Ctrl and forward slash on the keyboard. So whatever is the language in which you are writing this code, so those comments symbols will be automatically inserted. So in case of C language, so automatically forward slashes will be put at the beginning of each line to comment them out. So here this is a Python program, so the same can be verified by clicking on this one. So the language is auto detected as Python. So this is how you basically write the commands in case of Python. Now let's coming to the variables. So what as we said, variables hold certain piece of information. Here speed is equal to 5 and the other speed is equal to 5.5. Basically there is a difference between this speed and this speed, because variables are case sensitive, because this is small s and this is capital S. These two are completely different. And average speed I am setting it as 5.5 kmph, and I am using double quotes. This usually is a string which we are going to see in this today's video, and I'll also talk about what is this none. So let's try to print all of these. So I can just print it. So I can just click on this play button, which basically runs. Okay, so here, so it is printing the first line, so ignore the next lines. So basically the first one is 5, next is 5.5, the average speed and name. So everything is being printed like this. So these are all the different. So although it is A's, but if you see the characters are completely different. So some has small a, some has capital A, and then there is underscore between each character, there is underscore at the beginning, and there is all caps which we call it as constant, we are going to see today. And we have underscore beginning at the beginning and end of this variable name. So these indicates different type of variables. Some are private variables, some are public variables, some are constant. So we are going to talk about as we move forward with the course. and this is multiple assignment. XYZ is equal to 1 2.2 some DevOps. So X gets 1, Y gets 2.2, Z gets DevOps. So same value to multiple variables. You can also use this kind of a multi assignment. And now let's go back to the docstrings. So this is how you add the docstrings. So it is triple quoted string, and that too after the def keyword. So in case of classes, methods, anywhere you can just add these docstrings. So how do you access these docstrings? See here, I am trying to, so let's say that this particular function is in another file, so I don't want to open this file and see the complete functionality of that method, but I wanted to read the description. So here I can just call the function name, which is add, followed by the dot underscore underscore doc underscore underscore. Basically this is a special attribute. This is dedicated to the Python language, so you cannot use this as your own custom variable. This is by default, it is language specific and internally Python is using. Now if I try to run it, basically I'm going to get that description. So here this is description. It is a add method. It is expecting two parameters of either integer or float, and it is going to return the sum of the arguments passed. Let's say you're passing 2 and 3, it is going to return 5. So this is the docstring. So basically it is we are trying to print here where the method is defined here, but in usually these methods are defined in some other files, and this calling will happen in the main file where you wanted to see this description. Here, what is address of a variable? As we said, every variable is stored in a memory, so this will have the memory address. So how do you find the memory address where exactly this variable is storing? So as we already said, the X here is not pointing to the value, it is pointing to the address of that variable. So that means if you want to know the address of the variable, so I can use id function to get the id to get the address of the variable. Now let's say X is equal to 1. Okay, so X is now holding a value 1. I wanted to see the address of this X, so I can just use id, inside the square bracket just pass the variable name, which is X. So now I'm going to get this value, which is basically the memory address. Here understand this is 864. Now y is equal to 2, so this is another variable, y is equal to 2. And if I'm trying to print id of y, so I'm just getting 896. So if you see, there is a difference between 864 and 896. That means these two are storing in two different memory locations. Now if I try to get the difference, so there is a difference of 32 bytes. Okay, so why there is a difference of 32? So here X is equal to 1, which is basically a type of integer. So that integer needs 32 bytes of location to store. That means to go from minimum value to the maximum value this X can hold. So that is the memory size that it requires to reach to hold the maximum value, and after that only, so the next memory address will be assigned for the next variable. Now one of the interesting things here, let's say X is 1 and I am saying Y is also 1. So if I try to print X is equal to X's address using the id function, so I'm going to get some address value. Here it is 320. Now I'm assigning Y is equal to 1 and I'm also trying to print address of Y, but strangely I also got the same address. So why this is happening? So this has to do with the memory management in Python. So here what Python does here is X is holding the value of 1, Y is also holding the value of 1. Now instead of storing this value in two different memory locations, so it stores the value only once. Now it will point X and Y both to the same memory location, which is actually holding the value of 1. So this is called memory management, where X and Y, instead of holding the value directly, they will point to the memory location that is holding the value. So this is kind of memory saving a feature, where instead of storing the value twice, they are being stored value only once. So I'm just going to prove this. So I'll start a new file. So here I'm just doing x is equal to 1, and then I'm just going to print the id of 1, sorry, id of x. So I'm just going to change this to Python, otherwise it won't work. Or else what you can do is you can simply put control s and then just to test dot py file and then change it to all files. So now just run it. S- uh, just click on this play button here. So if you see, there is one address, so it is 152. Now let's do one thing. Let's print y is equal to 2. Let's do y is equal to 2 and try to print this same, the address of y. Try to run it. Now here there is a difference. So there is a difference between 8 and 40, which is basically 32. So we'll understand why is that difference. Now let's change from y equal to 2 to y equal to 1 and try to run it. So now if you see, they are both pointing to the same memory location. Basically this memory location is holding the value of 1. That's why x and y are both pointing to the same memory location. So this is called memory management in case of Python. Now what is a data type? So far we said x is equal to 1, y is equal to 2, or speed is equal to 5.5 kmph. So we were saying like speed is equal to 5.5 kmph in the double quotes. So these variables can hold multiple types of data. So some variables can hold integers, some variables can hold float, which is basically a floating point number. Some variables can hold booleans, which are true and false. Some can variable hold strings, and some can hold complex numbers, which has complex part and the real part. And in case of Python, there are other types of data types like the list, tuple, set, and dictionary, which we are going to see in the later. And memory will be assigned in the actual memory depending upon the type of the variable that we are using in our program. So the memory will be assigned differently for string, differently for integers, differently for complex numbers, etc. And Python doesn't in Python, variables do not need any explicit declaration of the type. That means in case of C language, so we are saying int a is equal to 1, which a can only hold the integer data. Or let's say that we are using float, pi is equal to 3.14, which is basically the value of pi, which is a floating point number. Here this pi variable has to be declared with float as the data type to hold the floating point number. But in case of Python, it is not like that. There is no need of putting the data type when you're declaring a variable, because in Python the data type is allowed to change during the runtime of the program. That is the reason why we don't actually give the data type. Here let's say that x is equal to 1. Here it is holding then integer data. Now during the runtime, I can make it to 3.14, which is basically holding a floating point number. And during the program, I can also make it to none. So basically I can also make it as a null value. So that's the reason why we do not actually specify the data type. And one more important concept which we are going to again see in the coming videos: everything in Python is a object. So you take x, we say that x is a variable, but it is also kind of an object. Let's say a bird is an object or a cat is an object. So what is an object is, it is derived from a class. So it is, let's say birds are derived from animals. So let's say a cat is derived from animals. So animals, here we call it as classes or blueprints, and all the cat, dogs, we call them as objects. So now these objects has various various feature, various different features between each object. So we call them as attributes and methods. Let's say that there is a bird, I'm just calling it as an object. So this bird has a color, a weight, a size, etc. So these are called basically attributes, and these are fixed. Let's say a bird can sing, a bird can fly. So these are called methods because they does something. Like bird, it is doing some kind of a work by singing or by flying. So these are called methods. Every everything in Python is called as an object. That means it has a name and it can do something. So we'll understand that in the coming videos also. Now let's talk about the data types. Here, hello world. So hello world is enclosed in single quotes. You can also use double quotes. So when you have something like this, it is basically a string. Now we have int num. So this is basically a variable name. So you can use x here, you can use y here, and here int underscore number is 10. Basically 10 is an integer, 10.2 is a float, 3.14 is just a complex number, and we have x is equal to true and y is equal to false. So both of them are booleans. Here t and f should be capital in case of Python. And we have other data types like the list, tuple, which is basically a list of elements. It will have square brackets, it will have circular brackets, and then we have the dictionary, which is kind of a key value pair. This is a key, this is a value, this is the key, this is a value, and enclosed in the flower brackets like this, curly braces. We have the set. Basically they'll have some elements enclosed in the curly bracket. So these are all the custom data types. We'll see them in the dedicated lecture. These are the standard ones: string, integer, float, complex, and we have boolean. Now what is none keyword? So none keyword is one of the, it's not like a data type, it's, we call it as a placeholder. So it defines a null value or no value at all. Let's say you have age. So here you don't have any value yet, so you can't put 20, 30 or any integer. In that case, so if you put like this in your program and if you try to execute it, so let's say that I'm just using simply, I'll delete everything and just doing age is equal to, and I'm trying to run this. So this throws an error because we this is an error here, expected an expression. So after equal to there should be something, but I don't have that value. Now I can just simply put it like none. So that means like age is equal to none. So here later during the program execution or later I can replace age with the actual number. So now if I run it, so it will run perfectly because I just used some placeholder which is basically a null value. And one more thing is, in case of functions, right, you are calling a function but that function doesn't return any value. So by default it returns a value known as none. So if you just check the type or the result of a function which doesn't return anything, so it will return none. So basically none comes, none has its own data type called the none type. So the name is itself none type. Now how do you find the data type? So by looking at the value the variable is holding, so I can say that it is an integer, float, a string, or an basically a complex number. But how do the program know? So basically it uses a type function. So inside this type function you basically pass any variable name, it is going to get you the type of the variable. Let's say, so here x is equal to 1. Okay, let me cut this piece of code from here. Let me copy into a new file. Here speed, average speed, and some name is equal to none. See here what I'm doing, so I'll just use 1 for now. So here I'm using a type function. Basically the function will start with the brackets and end with the bracket. Inside it I'm just typing the variable name, which is speed, and I'm trying to print it. So if you run it, so you're going to get the value. So I have to save it first and then run it again. So here it is class int. So why it is class int? So why not it is int? So as I said already, everything in Python is an object. That means it belongs to a certain class. Here this speed, so although it is a variable that is holding a fixed number here, it still belongs to a class, thus acting like an object. So let's say now I wanted to print the type of the other variable with capital S. If I run it now, it is going to be a float because it is a floating point number. Similarly for average speed, so average speed, this should return the integer. So it is of str, so str indicates it is an integer. And for this name I just mentioned it as none because there is no value as of now. So if I just type name and then try to run it, so basically it is going to just say it is none type, because none type is again a separate data type called none type. Let's go to the presentation again. So now we understood what is the type and why do we use it. Now we are saying that everything is an object in Python. So how come everything is an object in Python? So if we have to prove that everything is an object in Python, so let's take an example. So the example is, so I'm just writing my name here. So this is just a string, so name is nothing but a string. So this string is not an object in case if you're coming from other programming languages, but in case of Python, so everything is an object. That means it can have various methods also. So if I use a dot operator to call another method on that object, so let's say I wanted to use upper method. So here, if this is just a variable, how come I'm just calling another method? So only if this name is an object I can call the methods. Let's see, by printing the whole thing. I'll just save it. It is capitalized. So that means this name, although it is pointing the string, it is an object, and that object can have various attributes and methods. So we are going to talk about in depth in the coming sessions. So here this fruits, basically it is a list of some fruits, and on that fruits I can call the append method and add one more fruit. And now if you try to print that fruits, it is going to give you the added element. So let's say, so I have three fruits defined as a list. Now I'm going to print fruits dot append. I'm just calling an append method on the fruits list, and I'm going to add melon like this, and I'm going to print. So here it is saying it is a null value. Okay, so I just have to print. So once I add them, I can just use fruits like this, and then if you try to run it, so basically this melon is appended to the original list. So this is why we call that everything is an object in Python. Here fruits, even though it is being a list, it is still having it is still behaving like an object, and then it is able to call some functions. Now how do you find the size of a variable? So far we said there are different types of variables like integer, float, strings, and then boolean. So how do you find the size of an array variable? So using a function called getsizeof from the sys library, so you can find the size of an variable. Basically in Python, integer, float, boolean all requires minimum of 24 bytes on a 32-bit machine and a 64-bit machine, but it may vary as per your hardware. So if you want to see what is the memory that your integer is occupying, let's say x is equal to 1, so how much size it occupies. So let's try to find out using the sys.getSizeOf function, and before that you have to use import sys to import that library. So let's try to find out what is the size. I'm just taking this piece of code. Here import sys, which basically is importing the sys library or a sys module, x is equal to 1. So now I have some print statements which basically prints this value, which is x is equal to 1. This is a fixed string, x occupies sys.getSizeOf and these number of bytes. So if you don't know how to use it, so let's comment them by selecting and pressing control /. Now I'm just going to print sys.getSizeOf, and I'm going to pass x. So we basically x is holding 1. So if I run it, you can see 28 bytes it is occupying. So let's comment this thing out, and then let's uncomment the previous lines. So it's the same thing here, it will show x occupies these many bytes. So now x is 2.2. So this is why we call it as a Python is dynamically typed. Earlier x is 1, now x is 2.2, which is a float. Third time x is true, which is basically a boolean. So during the runtime I can easily change it. So let's run this. So here it is saying 1 occupies 28 bytes, a float value occupies 24 bytes, and a boolean occupies 28 bytes. So this is how you find the size that a particular variable occupies. Now what is this typecasting? So as we said, typecasting is a method of converting a variable type from one data type to another type. Let's say you wanted to compare a string. Let's say that you wanted to convert integer to a float, or a float to an integer, or a string to an integer, or an integer to a string. So all such conversions can be done using a typecasting. So typecasting usually done with various functions. So integer function, float function, and a string function. So let's say you are putting 1.1 inside this integer function. So this is a floating point number. Once you send it to integer function, it is going to give you the integer value. So let's prove this. So again, I'm going to go to the variables.py file, or typecast file. So here what I'm doing here, x is a 5, y is John. Okay, so this is basically a different example. See the conversions here. X is 5.5 and y is 10. Okay, so if I add both of them together, the answer will be 15.5. But here x 5.5, I'm just typecasting it to an integer. That means integer, inside the integer function I'm passing the x, which is basically a float. So 5.5 of integer, let's see what exactly is this. So for proving this, I'm just going to invoke the Python interpreter. So Python, so Python interpreter is invoked. Now I'm just saying x is equal to 5.5. Now let's see if I just pass this x to an integer function like this, which is basically typecasting. So now it has turned into 5, that is that extra dot 5, which is a floating point number, is removed. Now let's say I'm just doing str of x, that is a string of x. So here x is now changed into a string, that is why it has double single quotes. Now let's say that x is equal to some let's say 5. Now if I just use float of x, so now it is 5.0. So the x being an integer, it is now turned into a floating point number. So similarly it will work. Let's say that x is equal to, inside the single quote it is 3.14. Now if I just use x being a string, if I use integer of x like this, so it is invalid, because 3.14, it is a string, you cannot directly convert into a floating point, an integer. So string to integer, it is not possible. So the other way will be possible. Let's say x is equal to 3.14. I can use str of x to turn into a string, which is 3.14. So this is typecasting. So I have numerous example which is given in this file, and all these files will be checked into the Git repository. So now this is typecasting. Let's move forward. Now, what are global and local variables? So basically there are two types of variables. One is the global variable and the other one is the local variable. So global variables can be accessed throughout your program. So within any of the function blocks, anywhere you can use. But local variables are just restricted to a block of code. So if you come out of that block of code, that scope is lost. That means you can no longer access those local variables. So let's say that here temperature threshold is one variable which is assigned a value of 10, and now there is a function which is basically till here. So inside this function also we have the same variable with the another value. So now there won't be any collision here. So here this temp test threshold, it is within this function. So now outside the function there is also the same variable with a different one. let's say you're trying to print the temperature threshold within the function. So within the function, so 44 will be used. Now if you try to print the same outside the function, so the global variable is used, because the temperature threshold is equal to 44, it is within this function block, and this is a local to that function block. So once it comes out of that function, so this that scope is lost, and the program is going to consider the global scoped value. So I'm just going to prove this again. So we have another file known as local global. Here temperature, this is a global variable. So we have same in the define monitor temperature function block. This one is the local variable. Here I'm just printing like this, print threshold set inside the function. Okay, so it will going to print the 44 here, and outside the function I'm just saying threshold set globally, it is temp threshold. So let's see how exactly this works. I'm going to cut this and I'm going to paste it in a new file, so just to make it clear. Now I'm just running it. Now see here, threshold set inside the function, which is basically this, is 44 because this value is being referenced. Now threshold set globally is 30 because threshold is 30, which is a global variable. So how do I say that it is a global variable? So it is a global variable because it is defined at the root level. So it is not defined inside any function block like this, it is at the root level. So this becomes a global value. Now what are keywords? So keywords are, see, in Python, in any of the programming languages, so that programming languages uses certain words which the program doesn't want us to use them for our own purposes. So those are called keywords. So keywords are reserved words in any of the programming languages. So in C we have certain keywords that are reserved for that language. In Python also we have certain keywords that are reserved for the language. Let's say that def, if, else, for, range. So these are all the words that are defined for the language, and you cannot use them for your own variable names, etc. So these are called keywords, are also known as the identifiers. Currently there are 35 keywords supported. So in order to see all the keywords, right, so you can import the keyword module and then keyword dot kw list. So it will just print out the kw list. Now if you want to see the total number, so I can just send that keyword list to the length function like this. So more on the functions in the later part of the series. So if you pass it to the length function, you are going to get the total number of keywords. So basically keywords are the name. So if I just go to that keywords file and try to run it, so you are going to get all the keywords. So here false is a keyword, true is a keyword, none is a keyword. Similarly, so there are 35 keywords. So if I have to expand this, so else is a keyword, del, dev, so continue, everything is out the keywords. So you cannot use those words for naming the variables. Let's say I cannot use so keyword true is there, so I cannot use true is equal to 10. This is completely wrong because this true is not a variable name, it is a keyword. So that's the reason why we have x is equal to true, or this is the keyword which we are using. We cannot use them as the variable name. Similarly, we have something known as return. So I cannot say that return is equal to 22. It is completely wrong because this is the keyword, you cannot use it as a variable name. Now what are identifiers? So identifiers are the names that we give to variables, functions, classes, methods, etc. So here we are saying temp is equal to 40 and humidity is equal to 55. So these are called identifiers. So these are the names that we give to the variables or functions. So let's say I am declaring a function called adder function. So define adder. This adder is a identifier. So how do we name the identifiers or name the variables, functions? So what are the various conventions to be followed? So the conventions are identifiers cannot be keywords. So keywords like true, false, if, for, so you cannot do that. So these cannot be used as identifiers. And you can name identifiers with the combinations of names and letters. So names from A to Z, small a to Z, and then it can also have the integers. and a special character known as underscore. So it is not hyphen, it is only underscore. So you can use the combination of anything like this. So name underscore 01, area 22, interest underscore rate. So this is how you use the identifiers. And at the same time, identifier cannot start with a digit. So I cannot say one age or 20 int something like. So it cannot start with an integer, and you cannot have special characters like at the rate of exclamation and nothing. And they are case sensitive, that is age and age are two different identifiers within the programming language, and you should take care that they should be very small, short and meaningful. Here my var, my underscore var, underscore my underscore var. So these are all the valid names, like my var with, which is in all caps, all are valid names. So what are invalid? So the ones with the starting with the digits, ones which are using the special characters other than underscore, and one which are having, blank spaces between the variable names. So let's say that you have a variable called my age. So if you want to define my age, you should have you should define my underscore age, or like my age in the same letters, or my age. So age is like a with capital letters, so you can use like this, but you cannot use my space age. So it is absolutely wrong way of naming an identifier. Now, what are multi-word names, and how do we use them? What are the various conventions? So let's say that variable names. Let's say you have multi-word variable names like my age, okay, temperature threshold, okay, number of college students. Okay, these are multi-word names. So how do we write the multi-word names? So in Python we have something known as puppet naming convention. So these are the standard naming conventions. So you can go to this link and see all the various standard conventions that we can follow. But in case of any programming languages, so there are three different ways of writing the multi-word names. So one is the camel case. So this represents a camel where the first letter of the first word should be small, and the letters of each word should be capitals like this. So this is called camel case. Basically this is not preferred in case of Python. This is absolutely not preferred. What is Pascal case is, so every word starting letter is capitalized. So this is how we write multi-word names. So here number of college graduates, so every word starting letter is capitalized. So the next one is snake case. Snake case means, so every word should be separated with underscore. So here number of college graduates, so every word is separated with underscore. In what scenarios we use these styles? So for writing the variables, you should use underscore. Let's say my underscore age or temp underscore threshold. This is how you write it. And for functions also it is same thing. Basically you will use the snake case. For classes and exceptions, it is basically a Pascal case. That means I have a class known as my class, so it is M capital my class. Or student class, so student, which is S, should be capital. So if it is a multi-word, so every letter of the word, the starting letter of the word should be capitalized. And now for naming the constants, so which one we have to use for the naming the constants? So let's say that your age is a fixed one. So if it is a variable one, you will put all small. But if it is a constant, so indicate that using capital letters, all capital letters. So basically there is no concept called constants in case of Python, but in case of C language it is a different concept. So you define a constant using const keyword. So const x is equal to 10. So here x is defined as a constant. So if you try to change this value during the runtime of the program, your program is going to throw an error. But in case of Python there is no concept of a constant. So you define a constant, or you represent a constant with the capital letter, but a's can be modified anytime in the program. So there is no concept called constant. And for various methods also you can use the snake case. So this is the standard convention that you have to follow. And what are constants? Basically constants are a type of variables whose value cannot be changed. But in case of Python it's not like that, because Python doesn't have a constant type. Okay, so we use constants to represent some fixed values, and that constant name as is being shown in this slide. So everything should be capital letters, and we define the values to them, but these values can be changed throughout the program. And usually all these constant while values are put in a separate file, so you can call it with your own name, but constants.py is the standard. And then you can import this file in any of the main files to consume those constant values. But in case of Python, you have the const keyword, and some pi is equal to 3.14, which is a floating point number. So basically, if you try to change this 3.14 in the program, it is going to throw an error. So let's try to prove this. So I'm just going to take this piece of code. I'll open the online C compiler and just try to do it. So I'm just writing online C compiler. I'm going to take any of the online IDEs, and then I'm going to paste this piece of code. So basically it is constant pi, floating point number pi is equal to 3.14, and I'm just trying to print that value. So if you run it, so you're going to get the pi value of pi is 3.14. So just before printing, so let's do one more thing. Let's assign some value to this pi called 4. So let's see if I try to modify it. So it is saying error assignment of read-only variable called pi. So because it is saying it is read-only variable, but if I switch to Python interpreter in the same IDE, and let's try to say age is equal to 22. So let's print age. In the next line, let's try to change age is equal to 33, and then try to print it. So this is not going to throw an error because there is so it is capital H, because in Python there are no constant types. So even though if you mention A's as all caps letters, it is not going to consider this as a constant. So that is the one drawback. Although you have various modules that can define constant, but that is beyond the scope of this lecture. So that's it for this lecture, and I'll see you in the next one. That's it for this video, guys. If you like our video, consider subscribing to our YouTube channel and joining our Facebook group. The links are given in the description below. You can also scan the QR codes being displayed in this video. And for any training requirements, you can join our Telegram channel where we post regular updates on our upcoming trainings. You can also WhatsApp us on the number being shown here. You can also drop us an email for any kind of training inquiries. Thank you.